Assalamu alaikum. I'm DIARRA. I'm from Mali. I'm going to explain one exercise on case study, which is the question 2. A company manufactures two products A and B. These products are processed in the same machine. It takes 10 minutes to process 1 unit of product A and 2 minutes of product for each unit of product B, and the machine operates for a maximum of 35 hours in a week. Product A requires 1 kg and B 0.5 kg of raw materials per unit, the supply of which is 600 per week. Market constraints on product B is known to be 800 units every week. Product A costs 5 rand per unit and sold at 10 rand. Product B costs 6 rand per unit and can be sold in the market at a unit price of 8 rand. Determine the number of units of A and B per week to maximize the profit. So meaning that we have to maximize, the objective is to maximize the profit. So we are going to do a table. So we are going to find out the variables. Here the variables are product A and product B. Those variables are the type of products produced. So A, then the limitation, then here just the time, process time. For product A, it's 10 minutes to process, and product B, 2 minutes. And B, 2 minutes to process. Then the limitation is 35 hours per week. 35 hours per week is equal to 2,100 minutes. And also we have product A requires 1 kg and B requires 0.5 kg of raw materials. So the raw materials kg. This one product that is 0.5 kg. So the limitation is 600 kg per week. And also they said a market constraint on product B is known to be 800 units every week. That means product A. Here the limitation of product B is 800. So here the profit there. As we can see, for the product A, the cost of product A is 5 rand and it can be sold at 10 rand. So to know the profit, we have to deduct the cost price from the sold price, which is equal to 10 minus 5. Same to product B also, which is equal to 6 minus 8 minus 6 product. Yeah. minus 10 haram minus 5 haram, which is equal to 5 haram. For product B, that B is 8 haram minus 6 haram, which is equal to 2 haram. So here is, because we have to maximize the profit, so it's x1 plus 2x2, and here x2 equal or more than 800 units, and for the raw material is x1 plus 0.5 x2 less than or equal to 600, and here we have 10 x1 plus 2 x2 less than or equal to 2100. So first job is we are going to put the variables. The variable is product type A and type B. A and product type B. And also we need to know the objective. The objective is maximize profit, which is z equal to x1 plus 2x2. That's the objective. We have to maximize the equation z x equal to x1 plus 2x2. Then we need to identify the constraint. The constraint are the others equation different from the objective. So the others equation is 10x1 plus 2x2. That's one constraint. Another constraint is 1 plus 0.5 x2. And then we have also x2 equal or more than 800. Then also we have x1. We know x1 must be more than or equal to 0. And also x2 more than or equal to 0. Those are the constraints. So now we need to plot the graph. I'm going to use a software because I don't have a tool. I'm going to use the graphical method calculator. So here, this is the graphical method calculator. So for our exercise, we have 2 variables and 3 constraints. Because for the x1 and x2, those are always more than 0. You can see this one. So we don't need to put another constraint. So the objective is to maximize. So our objective is to maximize this equation: 5x1 plus 2x2, 5x1 plus 2x2, 5x1 5 2x2, then one constant. The first constant is 10x1 plus 2x2, then x1 plus 2x2, then x1 plus 2x2, then x1 plus 2x2 less than or equal to 2100, because it's 35 hours per week. So we have to, this is the second constraint. The raw material is 1 x1 plus 0.5 x2 less than or equal to 600 kg. x1 and 0.5 x2 more less than or equal to 600 kg. And the last one is x2 equal or more than 800. Okay, so that means x1 is 0 here, x2 is 1, more than or equal to 800. So we make sure we put all the variables and the constraint correctly. All of them are correct. So now we need to find the solution. So we will see the graph. We will see the feasible area and also the objective point. So let's find the result. So this is our table. So this is the graph. The feasible area is here, as you can see. Step for landing. This is the feasible area. Those are the points. Got it now.